everyone. Hello, everyone. Thank you for attending today's webinar, Emerging Technologies Supporting the Use of Open Source Data, Bringing Geospatial Information from the World Together. My name is John Jordan. I'm the Executive Director of the National States Geographic Information Council. If you are unfamiliar with the organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like more information on how to get involved with NSGIC, please visit our website at www.nsgic.org. Some reminders for our call today. All attendees have been muted on entrance. There will be a time at the end of the presentation for questions and answers, so please place your questions into the chat box. They will be read aloud and answered at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for an email with that information. With that, I will now turn it over to our presenter, Clifford Allison, on behalf of TomTom. Thank you again for joining us.
So are you recording now?
Yes.
Oh, okay. All right. So good afternoon, everyone. Welcome to the TomTom presentation. In this webinar, we'll share our advancements in data sourcing, collection, and interoperability, providing common standards and practices for conflation of commercial, open source, and government source data sets. We'll additionally discuss emerging technologies supporting the greater use of open source data such as OpenStreetMap, and discuss our participation in industry alliances, including the Overture Maps Foundation and the mission to provide next generation map products by creating reliable, easy to use, and interoperable open map data. So I'm Cliff Allison. I'll be the moderator for the TomTom presentation. I'm your direct NSGIC contact, and I lead government advanced technology sales for TomTom. I'll include my information at the end of the presentation so you can take a photo of it. I'm joined today by two of my colleagues. The first presenter will be Ramachandra Kalaga, who we call RC. He's TomTom Vice President of Product Management and Strategy, and he'll provide the technology overview and market strategy. The second presenter will be Brandy Boyle, TomTom Manager of Maps, Sourcing, and Local Intelligence. She'll dig deeper into the technology and formats and will lead the discussion on TomTom sourcing and map production. We have lots to say, so please put your questions in the chat. And our intention is to finish and have about 15 minutes at the end of the presentation for questions and answers. So let's get started, and I turn the presentation over to RC.
Thank you, Cliff. Hello, everybody. Good afternoon. Welcome to this session. I'll be covering today what we call as TomTom Orbis Maps. That's the name of the new map that we've been working on and that will be that we're releasing. It's a new standard in map making, and a bit of context to our strategy and how we are evolved to the Orbis maps. So what we've seen in the past couple of years is a lot of evolution in the industries and varying needs for location technologies. It ranges from electrification, a lot of vehicle safety. There's the whole concept of software-defined vehicles, where it's mainly automotive, where it's mainly driven by software and over-the-air updates, and your traditional businesses like delivery solutions, food delivery, ride-hailing, etc., where the need for better ETAs and delivery solutions are needed, and future use cases, which is mainly about IoT, industrial IoT, your digital twins, etc. So looking at this evolving tech and evolving use cases, how do we and what are the current options that customers have for geospatial data? On the next slide, what you see is what are the current challenges that and the solutions that are currently available in the market is you are typically working with proprietary map data providers. That's an option choice you have, or you're building it yourself. Needs a lot of it's a costly and time-consuming exercise to build and maintain, or you're using open data, and each of these have their own pros and cons. And one of the key things is across all these different provider types, the interoperability and moving from one provider to the other is a costly exercise. And the question is, okay, how do we address that, and what can we do in this space? So on the next slide, that's where the Orbis Maps comes in. So Orbis is the name of the product that we are launching. It's a new standard in map making. It's about how do you collaborate in map making in terms of bringing the best the data sources together, in standardizing them and making it and using open standards in a way where more and more customers and users of geospatial data can build upon. So on the next slide so what do you get from the Orbis maps? So it mainly delivers rich map content, of course. So the use cases that I mentioned needs, and we've seen a lot of need for rich data, both in terms of the feature types as well as the positional accuracy. So richer map content, high quality and fresh. So you need to have a solution or a system that's able to keep a map up to date and publish a quality checked product that's published at a high frequency. Easy to integrate. So there's quite a lot of open source tools, and with the recent, I would say in the past 5 to 10 years, I would say significantly, OpenStreetMap has evolved as a standard where a lot of users use OpenStreetMap, and a lot of tools have evolved around that. So the question is, how do you have a map solution that can benefit from the community and the community collaboration in building tools around it? So ease of integration, flexibility and control. So yes, you can use open data, but every business and every company has their own data that they build and layer on top. So how do you bring that together, keep it continuously integrated with the rest of the data layers? And finally is the standardization and interoperability. So if you build something, how costly or easy is it? So that in case you want to change an underlying map supplier, how can you seamlessly do that? And that's what the Orbis Maps addresses in the way we make the maps. So on the next slide, it gives you an overview of the approach or the data flow that we look at. So what you see on the center, the TomTom Orbis Maps, this is a new mapping platform that TomTom has developed. This is a layered version AI-based CI/CD platform. So which means that every data and object that we bring into the platform is layered. They're kept separate depending on the IP sourcing and keeping in line with the licensing that our source providers give us. It is version, so every change we make is version, so you can roll back and you can make sure that the quality checks are done before you make the commit. It is a CI/CD platform, so all the different data layers, while produced independently, are actually cross-referenced in a way so that they're bound together when you deliver a map product instead of individual layers. So into this, you see at the bottom is one of the data sources that go into the platform. So Overture Maps. So Overture Maps as a foundation and as a project was launched in December of 2022. It was co-founded by Meta, Amazon, Microsoft, and TomTom. And the idea behind this Overture Foundation is threefold. One is to create standards for geospatial data. Second, build and offer a global entity reference system. It's basically like a stable ID, where any feature and object that you reference to the stable ID can persist in the systems. And third is it publishes data layers. So it does offer open data layers. So what we do is and in this Overture, it also uses OpenStreetMap as one of the sources for it. So this is one of the inputs into our mapping system, but it's also complemented with other proprietary data sources like probe data, sensor-derived observations. So sensor-derived observations is basically observations that come from vehicles that are running cameras and computer vision in the vehicles, which we've seen lately that most of the vehicles are now fitted with cameras. So that's a big source, a continuous source, and you need to have a system that's able to process that, be able to make sense out of it, and make a meaningful update to the map. And then we have our own survey vehicles and acquired data and thousands of other sources. And this together in the platform is then delivered in as a map product. So the product is in a PDF format. It's a protobuf format with OpenStreetMap semantics, so backwards compatible to that, and extendable with new object types that are not there in OpenStreetMap. For developers, it is delivered and made accessible through TomTom managed services and APIs, and then a full stack solution where you can build applications both on SDKs, both in vehicle and in mobile apps. So that's the main, I would say, the data flow and how this platform is used in making those maps. On the next slide is, so this is a bit like I mentioned on the Overture Foundation. Currently, Overture is publishing 4 datasets. I think the last release was in October, where there were 4 data layers that were published. There's a road network where where OpenStreetMap is used, and the layer is licensed under ODBL because it is a pass-through license from OpenStreetMap. Then you have building footprints, which is another layer that is built as a separate independent layer that is offered as part of Overture Maps. The third is points of interest, mainly contributed by Meta and Microsoft, and then admin areas where we take admin areas from OpenStreetMap, and then you offer solutions for geopol solutions in terms of your disputed borders and how the world sees the boundaries in different way. And like I said, the Overture Foundation does 3 main things: the entity reference system, structured schemas, and then publishing data through quality control process. On the next slide, and this is one of the inputs to the Maps platform. And then I mentioned about enriching the map data through proprietary sources. Probe data is still a major ingredient where TomTom has access to more than 600 million connected devices that gives us its location in real time. And then we use that information to build our live traffic product and services out of that. And then we archive the data from which we have machine learning tools or software that's running that's able to continuously identify changes that we then use to update the map. We use satellite imagery to complement that. We have our own survey vehicles. There's active community input, so basically community that is providing changes and inputs to the map, and then sensor-derived observations where we do get data every day for on roads, on signs, and lane boundaries. On the next slide, there's a quick overview of how the new map compares to our existing map. So the bottom is the Orbis and the top is the current map, which is a completely proprietary TomTom map and varying locations in the world. Now we also use the Orbis map as a foundation for our traffic services. So we take all the probe data, anonymized and de-identified probe data that we get. We map match to the underlying map, and then we build traffic solutions on top where there's traffic available as a flow feed where it's real-time speeds per segment. And then there's also an incident feed, which is about traffic jams, road closures, road works. And then if there's a jam, then we are able to track the jam through its life cycle, including head of the jam, the tail of the jam, the length of the jam, the travel time to traverse the jam, and some predictive analytics about the jam evolution in 15 minutes, 30 minutes, and 45 minutes increments looking ahead. And what we see with the Orbis map is there's more coverage now we see in our traffic product, which is comparing the top part of the slide to the bottom, where there's more coverage available from that. Yep, on the next slide. So on the sources, like I mentioned, mainly on the SDO of the sources that we get and the layers that we build. So we layer the whole product where we start with the base map, where a large part of it comes from Overture and OpenStreetMap. And then we clean that up, we normalize, we quarantine, we standardize it. And then on top of it, we layer our traffic services, our PY services, routing, your advanced display, and dynamic vehicle data. On the sensor-derived observations, like I mentioned, it's the largest global source that's currently available in more than 200 plus countries. On a daily basis, we get around 90 million kilometers of roads that's available that we use to process and update the map. It has the most comprehensive feature set that enables various use cases. It also supports enhanced use cases for driver user experience, like two-wheeler routing and pedestrian routing, last 100-meter solutions, mainly for delivery services. And it's future ready in the sense that it has a rich network, basically a routable graph, which is our expanding, and validated through the technology and the sources that we get in a continuously updatable form, and published for our customers to use. And then because it's a layered and versioned system, the platform also offers the solution for bring your own data, where to a defined object model, we can cross-reference and continuously integrate any customer's third-party data with the rest of the map layers within the system, so that the CI/CD aspect of the data integration is also taken care of through the platform. On the next slide. So this is a quick example of some of the standardization we do in OpenStreetMap. So there's an example of addressing and some of the tags that we have for PYs. And we have many more standards that we do here. So in OpenStreetMap, one of the key challenges customers who are using that will find is about how they are represented and the various free forms that you have that it gets represented in. And when and if you want to use it in a mapping system, I think one of the aspects is about bringing all of them together in a consistent way to represent, so that your downstream software is more can be used in a much consistent way. And then so what users get from the map is a standardized interoperable map because of the stable IDs that are persisted from both the OpenStreetMap as well as the IDs from Overture, which is the global entity reference systems, and that allows for easy consumption of users' own data. And then the product, like I mentioned, also is extended with content like speed profiles, or like traffic volume counts, or like live traffic that is not covered by OpenStreetMap. On the next slide is, okay, how do you get access to this product? So there are three ways that we make them available. One is the map as a map data itself. So it is mainly meant for customers who are running ETL jobs, where you're downloading data and you're putting it into your own systems. So that's the delivery through map data format. So it's a PBF, protobuf format with OSM object models. It's also available in NDS Live. NDS is Navigation Data Standard for automotive customers, and it's .live, meaning it is delivered with the continuous increments and updates as well, with all the deltas coming from the system. And for traffic, it's available. The traffic feeds are available with open location referencing. Open location referencing or OpenLR is a standard, and an open standard that TomTom started initiated, and now it's an open source for referencing the traffic data in a map agnostic way. So you can decode this onto any target map. And we also deliver the traffic data with OSM IDs so that you can link easily to OpenStreetMap in case that's where that's your underlying map. And this is delivered on a weekly basis. And then the second is through managed services. We have Maps APIs and SDKs, both the web SDKs and mobile SDKs for load. It's a load development effort solution if you want to build your own applications. And then finally, supporting tools, mainly what we call as map editing partnerships, which is about community editing and community inputs that we could take to quickly process and update the map system and publish through our products, as well as contribute back to the community wherever the data is licensed under ODB. And then on the next slide is this is mainly about the editing part. Like I mentioned, this is about editing, map edits that comes into the system with fast turnaround times. You can bring your own data where you can layer that on top of the rest of the data layers in the platform. And the system is also configured and software developed in a way where we can track the IP and the ownership of the data through the system so that we are properly managing the open source data versus proprietary data. And if it's a private data layer, as one of the bring your own data solutions, we can also make sure that the data doesn't leak across into any other data layers or to anyone else. So it's basically controlled and managed through the IP configuration and the licensing controls. And on the next slide, yeah, so finally, I think this is just a closure on the TomTom Orbis maps. So it's a new way to make the maps, mainly in terms of collaboration, bringing all the different various data sources together, acknowledging the fact that there are significant developments in tech happening related to cloud computing, the amount of data that's being generated through cars, through computer vision on the edge, which is the vehicles, and OpenStreetMap as a significant data source and an open data collaborated through community that forms the basis for the map. And now I'll hand over to Brandy, who will take us through a bit more into how we make the maps and what are the details on the sources.
Yeah, thanks, RC. Hi, everyone. Thanks so much for joining us today to learn more about TomTom and the latest developments with the Maps platform. My name is Brandy Boyle, and I represent our local intelligence team in the TomTom Maps sourcing organization. I'm located in Atlanta, Georgia, and I've been involved with NSGIC for about 3 years. So to build on what our colleagues in NSGIC may already know about TomTom, we thought it could be helpful to share some additional information about data sources that are used to build the TomTom map. So we can head into the next slide and talk a little bit about some categories of sources that TomTom is leveraging. So kind of starting in the bottom right corner, I guess, from open data sources in the community, some examples in this category are sources such as data that's made publicly available from federal, state, local agency GIS data, the National Address Database, Tiger Road center lines and census location data, U.S. Postal Service delivery locations. This could also include information that's provided from government authorities and departments of transportation, such as location data for temporary road closures due to road construction, major planned events, or even emergency weather situations. Active community input and feedback from end users through applications that's using TomTom data. This is also an important input, leveraging community mapping inputs such as OSM, as RC had mentioned before, and OSM project data, and really also promoting participation of the community in OSM projects as a corporate contributor. This is also a growing area for TomTom data sourcing. TomTom map editing partners from government organizations can play an important role in providing high quality data inputs. And of course, data from the Overture Maps Foundation community is the newest opportunity for data sourcing in this category. Looking at the left corner of the triangle there, kind of from data provided from TomTom Enterprise Partners, some examples in this category would include things like feature data purchased from providers who license data for use in TomTom products, such as satellite and aerial imagery, value-added points of interest and business locations, detailed address point and delivery locations, pickup and drop-off locations coming from rideshare partners. TomTom customers who are also participating as map editing partner contributors would be in this category of sourcing too. And then kind of at the top there, sensor data that's collected by TomTom and provided from TomTom automotive partners. RC touched on this just a little bit, but some examples in this category would be sources that are utilized from TomTom data collection devices, smartphone applications, mobile mapping units that provide street level images and detailed location information, probe data such as device location points, and then anonymous lines of vehicle travel that are aggregated for reference. Sensor-derived observations, RC talked about SDO a little bit. This is coming from vehicles that are equipped with sensors collecting data and translating into images such as speeds of vehicle, road sign images, road conditions, pavement, lane markings. So kind of the general categories of sources there. And I guess diving a little deeper into a few of the data inputs heading into the next slide. So talking about our TomTom mobile mapping units, TomTom does have a mobile mapping fleet of vehicles. It's collecting data in many countries around the world, of course, including the United States. And talking to some of you at the NSGIC annual conference in New Orleans, some folks were actually sharing some examples where they've seen TomTom vehicles spotted around the country collecting data, and that was really exciting to hear. The vehicles are out there on the roads, and one of the most important situations where TomTom mobile mapping vehicles are deployed for collection projects is related to areas of road construction, especially where changes are made in reality on major interstate highways, major toll roads, roads of really high volume traffic in major cities, corridors between major cities. So the local intelligence team in TomTom sourcing monitors the progress of these types of road construction projects in reality, and then the mobile mapping collection units are deployed to capture very current images for fresh information in these areas to provide high quality data sources for those high visibility map updates that need to happen really fast to keep the freshness and the currency updated. Next slide. Yep, thanks. Probe data is another location information that's typically coming from vehicles, could also be other devices using TomTom maps, and collecting location data passively, such as mobile phone apps. Sensor data, we talked a little bit about that before already, but SDO it is really a growing source for TomTom, especially with all the images and information that's translated coming from the vehicle sensors. Application analytics data, this is also utilized as source information for building the map and provides really helpful signals to identify where map updates are needed. So for example, utilizing search statistics from an application as a signal that may indicate things like new points of interest locations that might be missing from the map, or new addresses that could be added if they're not matching up with the search functionality that's coming from the data there. Active community input, or ACI, is another information source that's provided by end users of devices that are linked to probe data. So ACI is really high quality information that's validated with supporting sources such as imagery, again back to SDO, authoritative data, even local knowledge from the sourcing team. So one example of ACI is feedback that's delivered maybe from a mobile phone map data user, where additional map feedback and comments are added from the user at a location where they could indicate things like the road's closed at this location, or the restaurant name is changed at this location, or the speed limit on this road is changed. So ACI is really high value and high quality feedback that's coming from the end users. And then device properties data, this would be source information that indicates detailed information about the vehicle that a device is operated in. So for example, is the device operating in a passenger car or a commercial truck? Is the device operating an electric, hybrid, or standard combustion engine vehicle? These data can be used to calculate, again, specific signals for the map features in relation to the vehicle type. And thanks, next slide. And talking a little bit about AI-based systems. So here we have some examples about how the change detection from these automated data sources are validated using image and pattern recognition before the source data ingestion steps. And then after the source data is validated and normalized, then it's moved into the ingestion steps. So during ingestion, the map updates are triggered and are happening continuously with the incremental changes for each feature. So this provides a fresh map, ideally reflecting real world changes with a really short turnaround time between change in reality and change reflected in the map data. So another set of source data in TomTom Maps is delivered from trusted partners. So in TomTom Map sourcing, we have a dedicated team in our community and partnerships group that coordinates the map editing partnership program. This program is available to organizations that want to provide active participation with source inputs for their community or for users of their products that are powered by TomTom Maps. So heading into the next slide, we've got a video here. We're showing the introduction of this program. So.
It looks like the audio is not working, and I'm wondering if it's because Cliff is muted.
Yeah, it could be. Since Cliff is muted and sharing, yeah, we're missing some audio.
Yeah, thanks for that. Well, I can restart it. Could be tested it before, but that's probably right. Let me know now. Is there sound?
Roads don't just move us.
Yeah, there we go. Thanks, guys.
At TomTom, keeping our maps accurate and fresh is our highest priority. That's why we've created the latest addition to our map editing arsenal, the Map Partnerships Program. TomTom's Map Partnerships brings together a global map-making community of map editors, fresh data, and sources with best-in-class technologies to deliver a fresher map faster. The Map Partnerships Program opens TomTom's map-making process to trusted partners, allowing us to work together to deliver precise and timely maps. These partnerships power not only the maps, but also the movement of industries, companies, and people around the world. The Maps Partnerships Program offers the following benefits: the power of a global map editing community, combined with TomTom's quality and privacy guarantees. Processes and tools designed for your unique needs. Priority map editing, lead analysis, and processing. Customized training. Your team will be provided with user-friendly resources and instruction to help them enhance their skills at every level of expertise. With the Maps Partnerships Program, you can onboard and begin editing right away, or your team can devote more time to studying a specific area of mapping expertise. We also offer a suite of self-paced e-learning. Thanks to the Maps Partnership Program, we're continually making our maps better together.
Thanks, Cliff. So we can go on to the next slide here. Yeah, so the Map Editing Partners Program, it's really a great opportunity to have a direct impact on the TomTom data. So please do reach out to us if it could be something interesting for your organization, and we can provide some additional details for getting signed up. So So yeah, RC did talk a little bit about an introduction to our Orbis map, so we can kind of move on to the next slide. We wanted to circle back to talking about Orbis maps and kind of the architecture and the quality assurance process. So I know this is a rather a complex slide, but the main point here is that we wanted to show there's multiple source material quality checks and quality assurance steps that are happening in the map production process. So also the data quality feedback loops that are expanding with the contributors. So data validation steps for each feature are a part of the continuous stream of information that's coming between TomTom and the source providers. Next slide. So when we're talking about, for example, OpenStreetMap as a data source, we mentioned that earlier, and this feedback that may get provided from customers to indicate situations where maybe potential improvements in OSM features are available. There's definitely steps in place for collaborating with the OSM community to help resolve these feedback requests. And really, TomTom functions as part of the OSM community and works to follow all of the community guidelines, as well as building opportunities to expand participation in the OSM project globally. And then, of course, preventing data issues means that TomTom's continuously validating content and using manual and automatic quality checks as part of the feedback process here. Next slide. Again, this slide is a little complex, but we wanted to show an example of what a sample request content summary for Orbis map could look like for a potential customer. So there's different options for how sample data could be provided and can depend on what type of data licensing a customer needs. So in this example, the base map content, which is open database license or ODBL compliant, could come from open sources, and the OSM complementary layer could be built on top of that base map. Value add layers from OSM can be provided that they're either from OSM or they're derivative layers. And also the TomTom value add layers on the top provide features that could be a little bit more complex or deliver advanced capabilities for navigation applications. So really the point here is the opportunity for collaboration and for customization depending on the use case for the customer. And that's a little bit more detail here and different types of features that would be potentially available. And I think that kind of brings us now to our time slot for some questions. So I know Cliff's been monitoring the chat, so if there's any questions that we want to take a look at. And yeah, the slide here is kind of circling back to some examples about the collaboration with Overture and kind of embracing that open collaborative approach to map making. So we thought it might be helpful to kind of bring it back to this summary, displaying the foundation layers and then what could be built on top with Overture partners. So.
Yeah, so we have two questions if I'm looking at the chat. The first one is from John Fix, and it says, I may have missed this, but what data does TomTom move back into OSM? So maybe RC, you might talk about that methodology of how that works.
Yeah, you can hear me okay, right?
Yes.
Yep.
Yes, okay. Yeah. So there are, I think like Brandy showed, so there are many ways for us to share map data with the community. One is TomTom voluntarily shares mapping data right now as editing leads in OSM Task Manager, Map Roulette, and also making some of the sources available that are ODBL compliant. Second, we do a lot of map editing projects and lead the programs in geographic areas to improve the map and have editing parties. And then third, through the Overture Foundation, where it is a completely open source, the road network layer, all the contributions also go back through that.
Okay, then great. Then the second question I see is from mapping, and it says, does TomTom use shapefiles, and do they allow anyone in general to edit or suggest like Google? So it sounds like they want to get more understanding about our map update process community. Yeah.
So on the use shapefiles, our internal data store behind in our production system is not shapefiles. We have I think we use mainly Postgres there as a database where we load everything there. But when we publish the product, it is published as a PDF. And then there are open source tools to convert a PDF into shapefiles. We are still reviewing the strategy for the GIS customers. because, for example, we do already see like QGIS already supports a PDF format. And we are contemplating on file geodatabase as one of the potential GIS solutions for our customers. And then second, do we let anyone suggest an edit? Yes, the idea is, so if you look at the whole way we make the map, one of the input is coming through OpenStreetMap. So if any edits are happening on OpenStreetMap flow in, and then the map editing partnership that Brandy mentioned will be relevant for all those data layers that are TomTom proprietary. And so this is another channel and entry point for map edits. And in case the edits, since you can edit the full map, any edits that you do on a proprietary layer or a TomTom value add layer, we keep that. If it is on an ODBL layer, then again, through the contributions back to the community, we open source.
Okay, thanks. And we have a new question from Jeremy McMullen. So is TomTom pulling address data from the National Address Database, right? NAD?
Yep. Yeah, and I can kind of take that one, Cliff, because I know that's one of the kind of authoritative or government agency sources that we were talking about a little bit earlier, and that's definitely something that TomTom is paying attention to. So we would certainly advocate for the local and regional and municipal governments to contribute to their state level data, and that state level data that's going into the National Address Database can be really helpful for any commercial mapping company that's trying to get authoritative data for addressing. So definitely keep up the great work with the National Address Database. I know it's been really growing so much in the past few years, and it's something we pay attention to a lot. So.
Okay, great. Thanks, Brandy. And then I think a follow-up question to the shapefile question from mapping says, so if we were to contribute a shapefile to TomTom, you would then turn it into a PDF? I think you said
into a PDF. Yeah.
Yeah, let's clarify.
So the
PBF or PDF. Maybe.
Yeah, I think it is a PBF, protobuf. That's the product format in which we publish. So yes, so any data layer that comes in as an input, it will be one of the sources that we will use in our production system. And depending on the feature that the shapefile relates to, it gets updated if it's a relevant update in our data store, and then gets published through the protobuf release.
Okay, great. So yeah, so I think that's all the questions so far. We have about 15 minutes left if someone wants to ask another question. Okay, great. So another question from Mark Lightsell. What efforts are made to identify height, weight restricted route to detour truck traffic?
Yeah, so in our PBF, in the Orbis map, we do have a logistics layer, and currently this logistics layer, which is all about truck height, weight restrictions. In the US, you have the truck preferred routes, the STAA routes, the weighing stations, everything related to truck routing is a TomTom value added layer. So which means we don't use any data yet coming, if at all it's there in OpenStreetMap. It's a proprietary layer that we curate, source ourselves, and then we publish that as a layer within the Orbis PDF.
Okay, great.
And then of course we use DO and other sources to maintain and update that.
Okay.
Yeah, and something that's taken into consideration for that layer too is just identifying, any of the ordinances or things that, legal information that's provided from the jurisdictions that have, supervisory information over the height, weight restriction. We also, work with partners that provide information that's curated. So, also things coming from like the National Bridge Inventory, those would be, again, sources that are open and available from authoritative agencies or from governments that we can also utilize to help create that logistics layer that's going to provide more detailed information about where trucks are allowed to go and where they're not allowed to go. So helping facilitate the safety aspect of making sure that trucks are not driving someplace that they shouldn't be going. And another piece to that is also, related to temporary road closures and the status of road network too. So as long as trucks are utilizing the proper data format, sometimes we do get feedback from users that have experienced trucks that are using an application, maybe not necessarily a TomTom application, but that may be using a mapping application that's not specifically designed for trucks, and maybe routing trucks on locations where only passenger vehicles are allowed. So it's really important for trucks to also utilize the right type of navigation source. So.
Okay, great, thanks. So we have another question from mapping. It says, so I can share my POI data and so forth, so they can see this on a device like a tourist might see. So I think it's, you know, the question is, can they contribute POIs, and can we, you know, put them back into the community? You want to try that?
So the POI, so it depends on the POI category and the type, but in principle, yes. The device, it depends on the data powering the application in the device. If it's based on TomTom data, yes, it does go back to the customers.
Okay, great. So I'm looking at the chat. We don't have any questions, but we do have another 10 minutes. So please do ask if you're contemplating one. Also, while we're waiting for the next question, you know, if you have a chance, take a picture of this screen, and you'll have the contact information. I would be your direct contact to NSGIC into TomTom. And if you want to have additional questions about sourcing, and we do want your data, so please do share if you're able to. Brandy Boyle, you know, would be the direct contact for that. So
yeah, I know something we talked about with a few participants at the NSGIC annual conference was kind of a big point was trying to get traffic data or authoritative information about traffic incidents or road incidents, you know, back to all commercial mapping suppliers. And so that's something that we're always looking for opportunities where there's automated data feeds that come in. So for example, like the 511 data that's happening for the state departments of transportation, anytime that we can get access to those automated data feeds for real-time incorporation into our live map product, that's of course going to impact safety. So if that's the case and you're interested in trying to confirm if your state or if your Department of Transportation is already providing that feed to TomTom, I can link that back to our sourcing team for the live map. And that's really important because that one really impacts a lot of safety, and especially with unplanned events or you know, vehicle accidents or weather incidents that are unanticipated, with road closures that are happening that could impact safety and routing for sure. Any application that's using TomTom live map data for that type of feature would be great to have the authoritative feeds coming in for where the incident data is being provided. So.
okay, any other questions? Somebody ask a real hard question. We'll give it a couple more minutes.
Yeah, so I guess maybe one thing I can also pop in the chat here too. There's some great updates also about Orbis Maps on our TomTom website. So it's kind of a good FAQ with this new product and what's available, maybe how it's distinguished. You know, TomTom Orbis Maps, how it's distinguished from Overture. So I'll pop that in the chat here. So that will give another link back to some FAQs. So let me get it into the group chat.
Yeah, we can see it.
Great.
Great, thanks, Brandy. So I think with that, should we turn it back over to NSGIC to close us out then? Or does anybody have?
That would be fine. Any other questions, please feel free to put your question in chat, but would like to thank Cliff and Brandy and RC for your time and a wonderful presentation, very informative. Thank you everyone who participated. Have a great day. And if we don't see or talk to you, have a happy and healthy holiday. Thank you all.
Great.
Thank
Thanks,
you.
everyone.
Everybody.
Thanks for
Bye-bye.
joining. Bye-bye.